In this problem, we're told that 3 randomly selected households are surveyed. The number of people in the households are 1, 2, and 12. We're going to take samples of size n equals 2. We're assuming that those are randomly selected with replacement from the population. So we're working with a really, really tiny population here. Right? So normally a population is going to have thousands in it, if not more. But we're working with this really tiny population because you're going to see there's a lot of computation here to do, even with this small population. So that's why it's limited the way it is. So listed below are the 9 different samples that are possible when you have a population of 3 and you're taking samples of size 2. So we're going to pair 1 with itself, and then 1 with 2, 1 with 12, 2 with 1, 2 with 2, and notice that it's with replacement, so you can have something paired with itself, and so on and so forth. So we're going to find the variance of each of the 9 samples. So how are we going to go about doing that? So we want to take the first sample, which is 1 and 1, and in the calculator, what I'm going to do is find the sample standard deviation, S, and then I'm going to square that value. So how would I do that? I start by going into my lists, and in list 1, I put in the numbers 1 and 1. So I've got that here. And then I exit out by pressing second and mode. And then I'm going to run one variable statistics with just list 1. So you can see that here. Notice that frequency list is blank. Okay, so there's nothing here. And when I press calculate, or arrow down to that so that it's highlighted and press enter, this is what I get as a result. So what we're concerned with is the sample standard deviation, Sx. And in this case, that turns out to be 0. So anytime that you have the 2 numbers are the same, the standard deviation is going to be 0. And so the variance would also be 0. All I have to do is square 0, and I get 0. So we know that without actually having to do any computation in the calculator. Then I'm going to go through and do the same thing for 1 and 2. So I need to go back and I need to change L1 to the numbers 1 and 2 and then follow these same steps. So here I've done the same thing. Now I have the numbers 1 and 2. List is L1, frequency list is blank, calculate, and now we've got one variable stats, and my standard deviation is 0.707106, blah, blah, blah. But I don't want the standard deviation, I want the variance. I need S squared. So what I do to calculate that, you can either write this number down and then just square it in your calculator, and that's easy enough. But what you can also do is choose variables. So here I am in the variables menu, and you have a vars key on your calculator. So when you press that, the variables window comes up, and we want to choose number 5, statistics. So you can scroll down and press enter, or you can just press the number 5. And that will bring up the statistics variables window. And you can see that here. And here's Sx. So there's number 3 is my sample standard deviation. And when I choose that, Then I can square that variable in the calculator, and I don't have to type this whole thing. I don't have to remember it or type it in. So here's what I get. And I can see that the variance, the sample variance, is equal to 0.5. So that was the sample variance for the sample containing the numbers 1 and 2. So what I can do is also look for the sample where I have the numbers 2 and 1. That's going to have the same variance. So this speeds up the process a little bit. So now I'm going to go back in. I'm going to change the numbers to 1 and 12 and then go through this whole same process again and find the sample variance. Okay, so I went through those same steps again with the calculator, and I got 60.5 for my variance. So I can copy that over here. That's 60.5. I know whenever the numbers are the same that the variance is equal to 0. So I'm going to fill those in. So that just leaves 2 and 12. And for the variance, I get 50. Okay. So now, now that we've done all that work, we can get started with part A. So we want to find the variance of each of the 9 samples. We did that. And then summarize the sampling distribution of the variances. So I'm just going to write my distribution here. And so here's S squared, and here is my probability. So my first value for S squared is 0, and I have 3 of those out of the 9. So I put 0, and then this is 3 over 9. In lowest terms, that's 1/3. Then what's my next biggest number? In my math lab or my stat lab, they're going to go in order from small to large. So next number is 0.5, and we had 2 of those. So mathematically, this isn't really necessary to go in order from small to large, but they need some way to be able to grade your assignment, and just they don't have the ability to be flexible about that. So that's what's going on there. The next biggest number is 50. And that's going to be 2/9. And then 60.5. And that's also 2 out of the 9. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, and I just count how many I have of each of those, each of the different sample variances. So now this is my table. And when we fill that in, that's part A. The next part, they're going to ask me if the mean of the sample variances is equal to the population variance. Because we know that sample variance is a good estimator of the population variance, we know that those are going to turn out to be equal. But what I want to do with this in order to verify that is I'm going to put S squared values into L1, probabilities into L2, and then I'm going to run one variable stats, where my list is L1, and my frequency list is L2. Okay. So once I do that, okay, So I entered my sampling distribution into the calculator, and I ran one variable stats with L1 as the list and L2 as the frequency list. And what I'm looking for is the mean of the variances. So that's the 24.666 and so on. So this is what I'm looking for here, not the population variance or this, I should say the population standard deviation or the sample standard deviation, but the mean of the variances is what we're looking for there. So that part is done, and I want to compare that to the population variance. So what would I get if I just put the values from the original population into the calculator and did one var stats? Okay, so I put my list into the calculator, 1, 2, and 12, and I found the population standard deviation, which was 4.966 and so on. And then I took that value and squared it and got 24.666. I got the same value that I did over here, and that's what I expected. So since these two are the same, then we say that the sample variance is a good estimator of the population variance. So that's how you do that problem.